evening Umesh, good evening Razak, good evening Ranjan Singh, good evening Rajib, good evening Ranjan Singh, good evening Bhishma. Good evening all. So, welcome to the GTQ programming of GATE 2022. Myself Ram Kumar. So, here we are going to talk about some important GATE model questions related to computer networks. So, while solving the question, so just to observe the question, take 1 or half means 30 seconds and try to solve it. So, I will give basically I am going to give the hints also parallelly. So, I am also going to solve along with you. Okay. So, here this is one question. They are asking regarding what? The routing algorithms. See, A, B, C, D, these all are the routers, and the delay between A and B, B to D, C to D, A to D, A to C has given. So, what information they are asking? Calculate the number of links which are unused once the routes are converged by the routers. Okay, so try this problem. So, basically parallel I am going to give the hints if you find some difficulty. See, basically in case of the routing algorithms, you know very well, like initially the routing table will be empty. Okay, as the time progresses, every router will be knowing the information of what? Directly connected paths, and that might be the estimated delay. And as the time progresses, routers are going to find some other alternate path, so that the estimated delay is going to become some other finalized path, then the estimated delay will be unused. So, based on that, they have used once the routes are converged. So, finally, which links are unused they are asking. So, try this problem. Good evening Arpit, good evening Shivam, good evening Nikhil, Umesh, Ranjan, Akshay, Patel, Komal Kumari, Nikhil, Mehendi Khan. Good evening to all. Okay, you can try this question. Okay, any routing algorithm, that properties will always remain the same. Good evening Patel, good evening Manikanta, good evening Bhishma Kumar. Yes, everybody is already solved. Good, very good. So, they are saying that answer is 0. So, how? See, for example, now here initially router A is connected to router B with how many units? It is 5. So, every router will be knowing the information of what? Directly connected path. So, this link is used. But can A and B or A either B, can they find any other alternate path which is smaller than this? No. So, this is the estimated delay, and this is the final delay, you can say. So, we can say this is used. Okay, like that. So, if you observe B to D, here also the link is 2. This is the estimated delay, and that becomes the final delay, because as the time progresses, this B and D cannot find any other alternate path which is smaller than this one. You can see that one. So, that is also used. Okay, like that. So, now you can see C to D is given as 4. Can C or D can find some other alternate path which is smaller than this? You can say 7 plus 5 plus 2, which is larger than this 4, but this 4 is smallest. So, this estimated delay will act as the final delay also. So, that is also used, and you can see this is also used. So, we might be in an illusion, sir, the value is more, so that might be unused. No, it is not like that. See, even 7, if you can find some other path, like you can 5 plus 2, 7, 7 plus 4, 11, 11 is largest. So, do not think that because that is the largest, it is unused. So, that is used. So, that estimated delay is going to become the final delay. So, as per this problem, you can see everything is used. So, the number of unused, how many? 0. 0 is the answer. Good, everybody has solved it. Rakesh, very good. Sombit, good, very good. Excellent. Everybody has told 0 is the answer. Fine. You can try this problem. Yes, this is the second problem. You can try. So this problem is also regarding the routing algorithms they have given. A, B, C are the routers and the delay between A to B is 1, A to C is 3, C to B is 1. They are asking how many links are unused by all routers once the routes are converged. Okay, so the meaning of converged means stable. Initially they might be having the estimated delay. As the time progresses, they can find some other alternate path which is smaller than the initial one. Then you can use a word like stable. So I hope you can try. I'm expecting the answer from all of you. Try. Yes, Pranshu, Raghavendra, Rajdeep, Jatin, okay, Gaurav, Atar. Yes, many people are telling the answer is 1. Answer Razib, very good. Moniksha, Pamneni, good. Umesh Chandra, 1, good, good. Bhishma Kumar saying it's 1. Excellent, everybody is solving, saying that it is 1. Let us see. I also going to solve along with you, no problem. Yes, they are asking how many links are unused. So you can see from this problem, I can say A to B, if it is connected, initially it is 1. So this is the estimated delay. But A can find some other alternate path to reach B, which is smaller than this one. 3 plus 1, it is 4. So it is larger. So this is the estimated delay and this is the final delay. So that is used. And any other things like thing? Okay. Now here you say A to C. What is this value? 3. Now this 3 is what? Estimated delay. Estimated delay initially. But as the time progresses, A can find some other alternate path to reach C? Yes, you can see via B he can find like this. But how it is possible? You know the definition of any routing algorithm. Every router will be knowing the information of directly connected path. Now see this initially this B to C is 1. It's very clear. But in the next iteration, when I use a word like next iteration, that means I plus plus, and you are comparing I lesser equal to, this B will send to A that I am connected to C, which is 1 unit. So I am sending to you. If you want, you use it. Then A will think, if I can send the data to B, B can forward to C. So 1 plus 1 is 2, But existing one is 3. So this 3 will be overridden by 2. Because this 2 is the smallest compared to this one. So then this is going to become what? Okay, final delay, final delay. That means what? As the time progresses, this estimated delay is converging towards what? Final delay. So this gives you an idea. A want to send any data packet which is coming from outside, then he can send the data to C via like this. So as the time progresses, because they use a word like converge, this link A to C link, okay, is unused. So they are asking how many links are unused by the routers. How many? 1. So what is the answer? B is the answer for it. Okay, so B is the answer. Good. Rajendra Kumar, very good. Lashya Sri, very good, excellent. Akshay, good. Razak, excellent. Okay. So the point in the case of routing algorithms, what you understand, as the time progresses, the estimated cost will converge towards the final cost. Then the estimated cost is going to be what? Unused. Because you find some other alternate path. 1 plus 1 is 2, which is smaller than the initial path. So the point is what? When the estimated cost is converging towards final cost, estimated costs are going to be unused. Okay, fine. So you can go with another question. This is also regarding some routing, means network layer, you can see. Is it not visible? Okay, it's okay. I'll bring it to center. Okay. Try. Mohit Manikanta. Good. Yes, it is given that A, B, C are having their routing tables. Now see the logic here. They are asking what would be the initial path. You observe the question. They are asking what would be the initial path for each one router A to transmit packets to which one? Router C. Initially they are asking. Komal, very good. Lashya, Karthik, Rena Rani, Bhishma, Pransu, okay, Rajkumar, Arya Singh, Monaksha, Saurav Patel, Raghavendra, Gaurav Atar. Sachin Kumar, when we apply any routing algorithm, these two properties will always be constant. Initially, routing table will be empty of a router. Any active device, it might be a router, a bridge, a gateway, any active device, initially the table will be empty. Okay, like that. Good. Sweta Pandey, Razak, good. Ansu, Prince Kumar, Sriza Patel, Divanshu, good. Yes, very good. It's very clear. The first property, you can see A to, okay, they are asking what would be the initial path to C, see router C, A to C. So A to C is how much? Initially it is 3. That's a direct path. For that, no need to apply any routing algorithm you use. The second property will always remains constant. Every router will be knowing the information of what? Directly connected routers. It might be for the routers, it might be the bridge for the layer 2 device. Okay, it might be all layer switch like gateway. That property will always remain same. So you can see A to C is a direct path. So from here you can eliminate that B. That's okay. Now what they are asking, what would be the path for router A to transmit to router C once the routes are converged? So how you are going to solve? See, it is something like B to C is 1. Then as the time progresses, B will send to A. I know how to reach C, which is 1 unit. So I am sending, if you want, you can use it. So when A wants to send the data to with a 1, so 1 plus 1, how much? It is 2. So we can say A to C is 2, but via with whom? B, you can say. Means the next hop will be what? This B. So here you can see this A to C is via B. Understand? So what is the answer? Yes. So A is the answer. Okay, see they are asking after once the routes are converged, you have to observe this point also, once the routes are converged. Shriza Patel, very good, excellent. Prince, very good. Anshu, Rishabha Jain, good. Bhishma Kumar, A. You can try the next model question. Remember, in this model, they have given some concept like periodic timer. You can say periodic timer. A, B, C are the routers. And what they have given, see A to B, how much? This is 3. And they have given B to C, how much it is? 4. It is 4. And C to A, it is 5. every router is using the periodic timer. So this is the most important point you observe. They are using the periodic timers. What would be the final routing table? Komal Kumari, Anshu, okay, Sarkar, Sombit. Yes. What is the purpose of periodic timer? If the routers, they don't use periodic timer for every route, what will happen? They are going to retain the previous value of the entry only. Even the other router is down, means crashed or not working. The routers are going to maintain the previous value, retain value they are going to store. That is the problem. But here you see they are saying that periodic timer is used. Periodic timer is used. When the periodic timers are used, what is the hint? What is the hint? Other routers will always send to the other router, I am connected to you, I am connected to you, like that they will say. So that time to time they are going to update, okay, like that. So that is the whole problem is here the periodic timer. What would be the final routing table of router A? Okay, they are asking the routing table of router A. They are asking routing table of router A. So here you have B and C na, like this. You know this is called destination. This is called the estimator final delay or the next hop it is. But remember here the question is once the router C is crashed. Router C is crashed means what? Router C is not working. They are asking that one. You observe that point. Yes, Anshu Kumar, you are giving the answer analysis also. Good, very good. Value will be flushed out. Yes, very good, excellent. Which value? Which value? Is it entry of B or is the entry of C? Karthik, good, very good. Ayush Vishwakarma, Manikanta, Raghavendra. Manikanta, just check that answer because here the periodic timer is using. Periodic timer you are using. Okay, okay, I will tell you the logic. Okay, most of the students has done correctly. See, here A to B is connected, na? Everybody they are using the periodic timer. So once the periodic timer is going to expire, B will send a periodically to A, I am connected to you, like that. Okay, understand? So here A to B will be 3 and it is dash directly. Okay, like that. But here A is using a periodic timer, C is also using, but what they said as the time progresses, here you see it is crashed. Once this person is crashed, he cannot send an update to A that I am connected to you. He also cannot send to B also. When he cannot send an update that I am connected to you, A also expects after a particular time that I should get an update from C, but you will not get because it expires. Then A is going to remove the previous value as somebody has said, it's going to be flushed out. So this will be vacant. This will be vacant. Okay, you can see and you can tell the answer for it. Tushar Nagapal, very good. Very good. Good, very good. Karthik, excellent. Raghavendra, Ranjan Singh, good, good, very good. Yes, what is the answer? C is the answer. Yes, you cannot keep C, B value because this 5 will not be there. This 5 will not be there. A is expecting that I should get a update periodically, but C is crashed. How it is possible? So entry is what? Removed. So C is the answer for it. Yes, it is given. You can say router C is crashed. Good, excellent. Yes, Raghavendra, correct. Karthik, Razak, very good. Tushar Nagapal, very good. Ranjan Singh, excellent. Yes, everybody has done. So you can go for the another model question. See, you can try. Take 1 minute or 30 seconds and try. Okay. Here you see the story here. The logic is they are saying that routers are not using periodic timers. Routers are not using periodic timers. Okay, try this one. And delay from A to B, how much? A to B is given as 3, B to C is given as 4, and C to A is given as 5. So you can see what would be the final routing table. They are asking for a routing table of A, routing table of A. You know, destination, estimated delay or final delay, next hop. But remember, here the routers are not using the periodic timer, the most important. What is the purpose of periodic timer? To know the status of the router, whether they are alive or not. Okay, whether they are crashed or not can be known. Manikanta, Komal, Varun Singh, very good. Sweta Pandey, excellent. Nitesh Kumar, Rani Malik, good, good. Yes, rounds, B for Bombay, very good. Analysis also good, very good. When the router is not using periodic timer, then the previous value will be maintained. Good, good, very good. Jatin Deep, good, good. Sachin Gangwar, B. Nikhil Sukla, B. Yes, Bhishma, excellent. Everybody is giving B as the answer. That means what? Here you can see B will send one time that it is connected to 3. A to B is 3 dash. Okay. Now here you see the periodic timers are not there. And here you see A to C, how much it is? Okay, it is 5 and dash. Okay, 3 plus 4 is largest. So this 5 is the estimated and this 5 is the final delay. Yes, what they are asking, what would be the final routing table of router A once the router C is crashed? Now you see the story. Here this router C is crashed. Even this C is crashed. This C is not using periodic timer, A is not using, B also, nobody using periodic timers. Then what will happen? Here what will happen means, any packets that are coming to router A asking that they want to go to router C, unknowingly router A is going to forward to router C where router C is not existing, because router A is going to retain previous value because timers are not there. Okay, that means here A is unnecessarily forwarding to a router which is not available. Router is down, crashed actually. So that is the actual mistake. Okay. Yes, what is the answer? You can see B, C, C. What is the answer? B is the answer. Good, everybody has done correctly. Ayush, very good, excellent. Sachin, good. Yes. Take some 20 minutes or 20 seconds or 30 seconds or 1 minute and try to solve this question. See, they are asking, it's means different layers they have mixed actually. Okay, it's not like specific to network layer. See, which of the following is true with respect to the networking protocols they are asking. Okay, try. Parallelly, I'll give the hints also. In the DNS, there are many servers are there, like local DNS server, root server, top level domain server, authoritative DNS server. These all are connected in hierarchy. The ultimate target is they are going to store your IP address when you give the host name. Okay, that is the actual logic I have given. Based on that, you try the first option whether it is true or not according to that. Okay, try. This is MSQ, okay, it is mentioned as MSQ, observe that also MSQ. Raj Kumar, ABC, good, good. Sarkar, ABC, Sombit, good, good. Excellent. Komal Kundu, okay. Neeraj Jaiswal, excellent. Anshu Kumar, Komal Kumari, good. Sweta Panda, correct, ABC. Akshaya Chatterjee, Koradia, ABC, good, good. Nikhil Sukla, Moniksha, ABC. Umesh Chandra, ABC. Rakesh Raj, Raghavendra, Yuvraj Singh, good, good. Excellent. Yes, good. So the point is here you can see the authoritative DNS server is store the IP address to the concerned host name. Yes, absolutely. So the point is when you don't get any IP address, first you are going to contact your operating system. If it's not available, it will be forwarded to local DNS server. If they are also not available, then it will go to the via which one? ISP and then to the root server. But see, root server is only going to collect the subset of the URL. Suppose like www.google.com, it will only absorb that .com. From there it will divert to this top level domain server. That top level domain server is going to divert to that Google. That means final IP address will be available at the authoritative DNS server. So it is true, it is correct. It is correct. It is going to give the reply. Going to give the reply. Shriza Patel, Sami. Sami is one other name. Okay, Sami. Raghavendra. Umesh Chandra. Good, good. Bhattacharya. Number of subnets given as 2 power k, where the number of subnets, if they have given a 0 subnet and DBA subnet is possible in classful addressing, you see in this classful addressing. Yes. Also, that means when they have mentioned 0 subnet and DBA subnet means netted is not possible in the classful addressing. Okay, so this is also correct. It's also correct. But otherwise, by default, the formula will be for what? 2 power k minus 2 for what? Classful addressing by default, because netted will be there and DB of a network also will be there. Okay, and that is given correctly also in the C. You can see it is also correct. See, the option B, option C, both belongs to, they are talking regarding what? Classful addressing, but not classless addressing. Okay. If they talk a classless addressing, that's a different story. You will observe the slash value and then you are going to decide the answer. So everything is correct here. A, B, C is correct. Because it's a MSK question. Good, very good, very good. Sami, good, good, correct. Raghavendra, correct. Excellent. Yes. Take some 20 seconds or 30 seconds or 1 minute. Try this question. And this question is also mixing of the protocols. They are talking about DHCP, ARP, BOOTP protocol. Take some time and try. Near as a Jaiswal, Kajal, Shifi World. Shifi World is very good name. Komal Kumari, Sombit. Sombit, excellent. ABC. Komal Kumari, good, very good. Pranshu, ABC, good, good. Razak, Rakesh Raz, Raghavendra, good, good. Sweta Pandey, ABC, telling. Anshu Kumar, Komal Kundu. Megha Naik, good, good. Sami, ABC, Nikhil Shukla, Mansi, excellent. Rajkumar, Rajkumar, you have to check B, okay? Once you check that B also, good. Bhattacharya, ABC, fine. Now you see the first one is what here? Good, excellent try, everybody. See, they are talking about DHCP, Dynamic Host Configuration Protocol. What is the hierarchy? You know very well, RARP, BOOTP and then DHCP. All are same purpose only. What is the purpose? When you give ultimate target is to assign IP address to a computer. But in RARP, there are some drawback is there. For N LAN networks, N RARP servers are required, so cost becomes very high. So then you shifted to BOOTP, where you require only one BOOTP server and N-1 relay agents. Okay, the ultimate target is to assign IP address only. But here they are not asking regarding that. Now you see they are asking both source and destination ports are fixed ports are used, whether it is true or not. Yes, absolutely, absolutely it is true. See, if it is a HTTP, the source port will be a dynamic port, destination port will be a fixed port like 80. If it is a SMTP also, when the source is sending, source will be the dynamic port and the destination port is a fixed port like 25. Okay. So how you are going to distinguish the remaining all protocols with this DHCP, especially this DHCP, both the source or destination will have fixed ports. 68 and 67, these two are fixed ports. So 0 to 1023, these are all fixed ports, predefined ports, fixed ports, universal ports we'll call it as. So it is true. Good, very good. Sonu Singh, good. Girish, excellent. ABC, okay, good, good. Now they are talking about ARP, Address Resolution Protocol. This question also last year also they have asked regarding this ARP. It is so simple. What is the purpose of ARP? ARP request is a broadcast, you know very well. It contains source IP, destination IP, source MAC. What does it will not contain? Destination MAC. So you are going to broadcast. Then ARP reply is a unicast. The whole purpose of ARP protocol is to collect the MAC address. Anyway, what they are saying? Purpose of ARP protocol is to get the MAC address. Okay, they are saying the same thing what we are analyzing from the given IP address. So it is also true. And you know this boot P is the predecessor, okay, of that DHCP is to get the IP address, to assign the IP address in a couple of seconds before what we have told. It's correct. So what is the answer? All are correct. So you can see this particular problem, it feels like a little bit easy, but so you have to learn all the three protocols and they have mixed and they have given. Okay, good. ABC. It is MSQ. Girish, very good. Yes, you can try this question. This question is regarding what? Fragmentation. Fragmentation they are asking. Means once you have the complete idea what is going to happen, you can easily solve it. It is quite logical, this question. Think. You know, I will give the hints also parallelly. When a packet comes to a LAN, when the packet size is more than MTU, definitely you have to do fragmentation. And there is a possibility that these fragments come at the out of order direction. So based on that, they have given some question here. Yes, DF means what? Don't fragment bit. If it is 0, what will happen? It's a fragment. If DF is equal to 1, it's a packet, you know. MF is going to tell all the intermediate fragments if it is 1 starting from the first. If it is 0, it's the last fragment. Fragment offset multiplied by 8 will give you the starting address of the fragment based on that. Based on the inputs what I am giving. So they have given some question. Fragment offset multiplied by 8 will give you the starting address of the fragment. Why 8? Because total length is 16, fragment offset is 13, difference is 3, 2 power 3, 8 is playing the role, 8 is playing the role. Kajal telling it is C, Sombit it is C, Arya Singh, very good. Prince, Neeraj Jaiswal, good. Yes, C is the answer, good. Lasha Sri Koradia, C, good, good, excellent. Sami, correct, correct. Neeraj Jaiswal, correct. Sweta Pandey, good, good. Raj Kumar, good. So here, what is happening is, the most important point is, it's quite common, it's a mathematics. The starting address of the first byte which is having for the packet, the same address will be available for the first byte of the first fragment. That is the logic behind this. Because that is from where there only you are dividing, no? So you can see in this problem, the packet size, what they have mentioned, the packet is fragmented as the packet size is more than MTU. It is divided into fragments. So they came out of order. You can see 80, 800, 1200, 400, 1600. So this will be the starting. And you know, observe one point here. Here, the fragment offset of this fragment will be same as the fragment offset of the packet also. Because the starting address of a packet will be same as the fragment offset of the first fragment. Okay, so where it is? First one, second one, third one it is. They came out of order. So what they are asking? At the receiver, fragments came out of order, fragment offset. Okay, they are asking. Then which of the following is the first fragment? Where is the first fragment for? Okay, third one. Jatin Deep Singh, good, good. Okay, like that. 400 means what is the meaning? 400 means what? Fragment offset is 400 means what? Fragment offset multiplied by 8 means 400 into 8. 3200 is the starting address of the first byte of that fragment actually. Okay, like that. Okay, somebody is asking, so now say I am explaining here. This is 400 na, I am writing here. It will be like this. Fragment offset definition I am explaining here. See, fragment offset definition is because they have given 13 bits na, so it is 400. 400 means what? Fragment offset multiplied by 8 will give you the starting address of the fragment. So 400 into 8 how much? Okay, 3200. So here the starting address will be 3200. So this is the 400. This is the first fragment you can say. When you say second fragment, after 400 where you got here, you can say it is 800. 800 into 8, that means you have 6400. So this is the starting address of the second fragment. Second fragment you can say. Okay, good, Sami, correct, good, good. If you want, you can say third fragment. Where is the third fragment like this? You can see after 800, this 1200. So 1200 into 8, because you know fragment offset multiplied by 8. Why you are multiplying by 8? Because if you observe the IP header fields, total length value will be 16 bits, fragment offset will be 13 bits. Difference is 3, so 2 power 3, 8 is playing the role. So this value becomes how much? 9600. So this 9600 will be the starting address of the third fragment. Yes, you can see the fourth fragment is how much? 1600. So this is the fourth fragment. 1600 into how much? 8. 00864 means 1 to 8 like this. Like this. Thank you, Tulsi Ram. Thank you. Yes, the difference is 3 bits. Scaling is 3 bits. Sami, good, very good. And you can see, since now you form some sequence, here the starting address is 6400, then the ending address value becomes 6390. Like that, you can know the size of the fragment also. Size of the fragment means what? Number of bytes in the fragment. Or I can say from the packet, whatever the bytes are there, those bytes you are distributing in every fragment. Like this you are distributing. If you want, you can say this is the 39600, then this becomes 9599. Like that you can know the size of the fragment. Yes, because now I have given example. Suppose if the MTU I have taken some example like 200, then I can write 20 and 120. 20 is the IP header, 120 is the payload value. But 180 cannot be the fragment because it is not a multiple of 8. So this gives you an idea. Okay, who asked this question? Jatin. Okay, so this gives you an idea. MTU can be somewhat larger than this value also or equal to also. Suppose if I have taken 200, okay, like that. Good, good. Thank you, Tulsi Ram. Thank you very much. Thank you, Vandit. Yes. Try this one. Take some 20 seconds or 30 seconds if you know the concept so well, or take a little more. You will be clearly understand. This question they are asking, you can see. Identification number. That means they are asking regarding what? IP protocol. I mean second row, left side, the identification number will be there. You can try. Rajkumar, Sombit, Sweta Pandey, Ranjesh Singh, Mohanakshi, Neeraj, good. Komal, Vanditsa, good, very good. Arya, excellent. Lashyasri, very good. Raman Singh, good, good. Programmer team, who is this programmer team? Good, good. From Jaipur. Bhishma Kumar, excellent. You are giving the analysis also because identification number is 16 bits. Good, very good. You are giving the concept behind also. Good. Yes, because you know very well what is the purpose of identification number. Whenever the source is sending packet, and if you do fragmentation also, fragments belonging to same packet will be having same identification number, same identification number. And you know IP protocol in the design, they have provided only 16 bits. So 0 to 2 power 16 minus 1, up to these numbers only identification numbers are possible. So which possibility is there? Yes, this is possibility is there. 8 is also there. Yes, it is possible. This is also possible. Yes, because 0 to 2 power 16 minus 1 means what? 0 to 65535. So which is not possible? You can see 2 power 32 minus not possible. So B is the answer. So this is the concept question, like 1 mark question they can give like this. Okay, good. Manikanta, Palak, Kasudan, Nitish, good, very good. Yes, Bhattacharya, correct. But you have put a value as 0 to 65534 na, Bhattacharya. It should be 0 to 65535. 535 should be there, not 3435. Okay. Swapnil, good. Good. Yes, now it is correct. 6 up to 65535, now it is correct. Good. So they can give for 1 mark. Such questions they can give in as 1 mark. Okay. Direct questions like once you know the field, they can substitute. What is the purpose of identification number? Fragments belonging to the same packet will be given same identification number, so that at the destination you can easily combine the fragments belonging to the same group. Okay, like that you can easily identify that value. Good. And this question is regarding the TCP concepts. Try, take some 20 seconds or 30 seconds or 40 seconds. Based on that, try. They have given some options. Swapnil, good, very good, excellent. Palak, good. Okay. So they are asking what? Regarding what? TCP. They are asking regarding TCP. It is not MSQ, check clearly, okay? Pransu, Nikhil, Vandit, okay, Raj Kumar, Sweta Pandey, Raman, Moniksha, okay. Okay, see the first logic, what they are writing, the sequence number of a segment is 100 to 199. That means what is the meaning? Here you are sending a segment, how much? 100 to 199. So what is the 100 sequence number of the first byte? 101 sequence number of second byte, 199 sequence number of the last byte. So what is the size of the segment? Here you can say that 100 bytes. But they are asking, is it a sync segment? No. Sync segment doesn't carry any data, but it consumes what? One sequence number, but it is consuming 100 sequence number. So you can say this is false. This is false. First one. Neeraj, Lashya, Sami, Rakesh Rajkut. Sequence number of a segment is given as m. The sequence number of subsequent segment must be. This is also false now. For example, say here only you can take this example. When you say this is m, okay, when you start sending the next segment, it will be starting from 200 to suppose say 299. So you can say, is it m plus 1? No, it can be m plus 100 also not. But they are saying that must be m plus 1. When does m plus 1 is possible? When you start sending a segment of only 1 byte, then only it's going to be possible. Okay, so that is false. Okay, like that. So that this is they are asking must be, that is the reason it is false. Yes, all are wrong, correct. Sami, correct. Here you see option C, segment encapsulate packet. It is also false, na? The concept is what? Always the lower layer is going to encapsulate the upper layer's data. Lower layer is going to encapsulate the upper layer's data. That means what? Frame encapsulate packet, yes. Packet encapsulate segment, yes. Segment encapsulate message, yes. But upper layer cannot encapsulate the lower layer. So that is also false. Okay, so what is the answer? D is the answer for it. D is the answer for it. Raj Kumar, good. Swami, correct. Deep Singh, good, good. Palak, you told correct. Okay, you have given the analysis. Reverse is correct. Packet encapsulate segment is correct. Good, good. Palak, correct. Try this one. Okay. Now say this question is also combinedly all layers, but while solving, you should remember the layers also, from which layer to which layer the data is going. Based on that, where the error control policies are calculated, that you will be knowing. Okay, not in a hurry, take some 30 seconds like that and you can try. See, they are asking, see, the correct order of calculations at sender side, this you have to observe. Okay, and remember the concept of the OSA model or TCP/IP model, where the layers are going to start. Based on that, the error control policies, in which layer what is going to be happen, you will be knowing. They are asking at the sender side, you see, at the sender side they are asking. Vandit, good, very good. Ranjan, Sweta, correct. Komal, correct. Good. Sagar, very good. Seema, Seema, good, very good. Karthik, good. Umesh, excellent. Panchal, B. Ansu Kumar, Anuj Kumar, good, good. Bhattacharya is telling the transport layer, network layer and the data link layer, good. Bhishma Kumar, very good. Raman Singh, Siraj Patel. So you know very well, the data it will start from application layer and then transport layer. Okay, presentation and session layer will be a part of application layer if you use a TCP IP model. Then what? Network layer, then the data link layer. So this is going to give an idea. So here at the transport layer, first calculation will be done. For what? Segment. So it is correct. After that, network layer is going to provide checksum for the entire packet. No, it is only for what? IP header, you know very well. Okay, so that's why here you see they haven't mentioned the checksum calculation for the packet. You see they are mentioning that IP header calculation, because you know IP protocol provides checksum only for what? IP header only. You know why? Processing time should be less, packet has to reach the destination correctly. If it reaches, you know very well. Okay, like that. And then the CRC calculation at the data link layer. Okay, good. Understand? So what is the order? It is available at where? Option B. Because you know, if I say that first CRC will come, does frame encapsulate packet or packet encapsulate frame? Frame encapsulate packet, but at the upper layer that packet calculation will be done now. So IP header calculation. So what is the answer? B is the answer for it. Yes, Pranshu, very good. Correct. Jatin, correct. Good, good. Rajkumar, correct. Yes, that's true. TCP is going to calculate checksum for the entire segment, end to end. Okay, good. Yes, you can try this one also. This is also a important model. Try. No, Pransu, see, actually IP header is only calculating the 20 to 60 bytes only. Okay, like that. Vandit, Nikhil, Kajal, Mansi, Rakesh, Raj, Meet Panchal. Okay, Ranjan Singh, Komal Kundu. Okay. Palak has given the analysis also end to end. Good. Sachin Gangwar, correct. Karthik, good, good. Saurav Patel, good. Yuvraj Singh Chauhan, Anush Kumar, okay. Good, good. TCP is used for end to end, so only 2 times calculated. Ankush, good. You are giving the analysis also. Good, good, very good. Yes, yes, correct. That means what? Here at the source, you know the data, it will start from application layer, then yes, transport layer, then network layer, then data link layer, and what? Physical layer. But the point is, you know, these routers are what? 3-layer devices only. So here, what will happen? The data link layer and network layer, and here the data link layer. So here also the data link layer and network layer and the data link layer. Okay, like that. And at the receiver side, all the headers are removed. Application layer, okay, data link layer header is removed, network layer header is removed, transporter header is removed, application layer header is removed. Now they are asking, you can say TCP checksum they are asking. So if you think routers will calculate, but where is the visibility of transport layer at the routers? No visibility. Okay. So where is the transport layer? You can see here at the source and here at the destination. So whatever you calculate here, whatever you get here, that is, call it as received TCP checksum, and again you calculate the TCP checksum at the receiver for comparison, then only the segment will be accepted. Okay, understand? Anupriya Mahato, good, good. Okay, Raman Singh, Sagar Lodia, good, good. Correct. Akash Chatterjee. Razak, yes, it is 2, good, good. So what is the answer? 2. C is the answer. Manikanta is asking, okay. Simple, because here at the source side you are going to calculate the TCP checksum and only at the receiver side. So if you ask me why only at source and destination, so simple, because of potential errors occurring inside the routers. So what will happen now? At this entry point, data link layer is going to, okay, at this area is called data link layer. Whatever you transmit is everything is frame only. Okay, in the class, whatever I have explained in the class, it will be in sequence, you can observe that. Okay, so here the TTL value will be decremented, again you will calculate the header checksum once it reach here, I am talking about network layer, okay, and again you calculate the checksum for comparison. If it is matching, accepted, packet will be transmitted. So at this interface only the data link layer headers also will be there. So data link layer header is removed first or network layer header is removed first, you have to follow that sequence, okay, like that. So there is no transport layer visibility, so only at the source and only at the destination only. Okay, what is the reason? TCP provides checksum because of potential errors occurring what? Inside the routers, only 2 times. Good, very good. You can try this one. Rajak is asking physical layer is available? Yes, that is true. Okay, so here the point is below the data link layer physical layer also will be there. But that is the reason these routers, we will call it as the 3-layer switches. If we use routers, physical, data link and network layer. If we use bridges, only physical and data link layer. If you use gateways, all layers are visible. It depends on which device you are using. Okay, like that. Yes, you can try this one. Based on the same model they have given. Vandit Rakash Raz, Komal Kumari, Raj Kumar. Rajkumar, definitely the TTL will be decremented, but TTL is a part of IP header. It's not a TCP header, no? Okay. Okay, fine. So listen this question carefully. I will explain. You are finding difficult here. See, many people here they are asking IP header checksum. I am going to explain. See, the point is here at the source application layer, then transport layer, okay, then network layer is there. So the logic is what? Here already TCP provides what? TCP checksum actually for the segment. Okay, let me explain. TCP checksum, it is going to provide for what? Segment. But once it come down to network layer, you know, in the network layer, data is known as what? Packet. So packet is nothing but what? Okay, IP header and data, IP header and data. And remember, in this IP header, especially first row, second row, third row, here you have TTL value. So the point is, when it is transmitting, the TTL value will be decremented at the source also. This is the most important point. But remember, this TTL decrementing is done at which layer? The network layer. Okay, after decrementing, then this network layer is going to calculate what? Header checksum. Okay, which header checksum? IP header checksum it is going to calculate. Okay, you have decremented na? Then after that you will calculate the IP header checksum. Okay, okay. Then after here data link layer will be there, CRC is there, CRC is also going to calculate. But here the question is regarding what? IP header only. So the point is, once the packet came here at this interface while it is receiving, this is the most important point. TTL will not decrement. TTL is going to be decremented only at the output interface only. But here also you will calculate the IP header checksum. IP header checksum you are going to calculate. For what? Verification. So at this interface, when you calculate the IP header, the calculated IP header, okay, checksum should be matching with the received header checksum. Then only the packet will be accepted. So here the point is, it might be a source or router. While forwarding, TTL value is decremented. After decrementing, you calculate the header checksum. But while receiving, you will not decrement. You will only calculate the header checksum for verification. Same thing, here it is going to decrement. After decrementing, you will calculate a checksum, IP header, and again you are going to calculate for verification. That's what we use a word like IP provides a checksum for the header so that packet will go to correct destination if it reaches. So if you observe clearly, here also TTL is decremented, but not here. Here also TTL will be decremented. So how many times it is decremented? 2 times. Okay, TTL is decremented. But how many times you are calculating the header checksum? You can see after decrementing you are calculating. Here also you calculate for comparison. After decrementing you are calculating. Here also you will calculate for comparison. So 4 times. Okay, IP header checksum. Okay, you are calculating for 4 times. So what they are asking? Now you can see how many times IP header checksum is calculated from source destination. How many times? Here and here and here and here. So B is the answer for it. Good. Moniksha, correct. Sarkar, very good. Vandit, very good. Kajal, good, very good. Remember, that is the most important point. Here it will decrement TTL, but at the input interface, it will not decrement. It will only calculate header checksum for verification to accept that packet. Okay, like that. Here also it will decrement and then you calculate a header checksum. And at this interface, you are going to be accepted for verification, like that. So, B is the answer. Because here the IP header is calculated for how many times? 4 times. Okay. But remember one important thing. After network layer, there is a data link layer. Definitely data link layer also is going to calculate, but it is not a checksum, it is a CRC, you know. Okay, like that. Okay. Vandit, understand? Good. Pransu, very good. Anshu, good, good. Yes, you can try this question. Same model they have given, TTL. They have given the initial value is 9. You know it is going to be decremented. So TTL value becomes what? 8. Is it decremented? No. Here it is decremented? Yes. TTL value becomes what? 7. So here you decrement, calculate the header checksum. Again here you calculate checksum but for comparison. Try. Patel, very good. Kushwaga. Palak. Okay, Vandit, Komal, Karthik, Saurabh, Sweta Pandey, Raman, Anus Kumar, good. Razak. Yes. So here it is decrementing 8, again decrementing 7. So again it is going to decrement. Okay. So it is 6. So what is TTL value? 6. So based on that you can see in some previous year questions this regarding TTL also will be available. So always remember, it will not decrement here, you observe that. It will not decrement here, only it is going to calculate header checksum for comparison. Here also, it will decrement, calculate the header checksum. Here you are going to calculate checksum for comparison. Sir, you can ask me, sir, when does at this point and at this point calculated header checksum should not be equal to received checksum? When noise modifies, and you know when noise modifies, that a calculated header checksum will not be equal to received header checksum. When the packet will be dropped and you know the remaining story, ICMP protocol will come and it is going to inform to source by sending which message? Parameter problem message, because some parameters are modified. Who modified? Noise. Okay, like that. Rakesh Raj, no, you can see that. Why does it will modify at the destination? No, it is not. Okay, at the destination it will not decrement. It will calculate a header checksum for comparison. Ankush, that is also correct. TTL is also used to measure the distance from source to destination. Yes, that is true. Ankush, that is correct. When you use a ping command, it is going to internally use this TTL value to find out where exactly the distance and how many hops are there. That also can be calculated. Good, correct. Santosh Kumar, correct, good, correct. You try this problem. They are asking, now you see the logic here. They are asking, you can see how many times data link layer headers. See, data link layer headers are attached and removed. This question also, this model question also one time they have given. For this one, you should know what are the different layers present at every device. Try. Rakesh Raj, you are asking us, sir, does the TTL is decremented by the destination? No. Okay. It will only calculate a header checksum for comparisons. Observe the layers, Rakesh, you will understand. Okay. Good. Very good. Vandit A. Sombit, very good. Yuvraj Singh, good name. Chauhan, 212. Rakesh, Komal, Komal Kundu, Komal Kumari, Sarkar, good. Saurav Patel, Ankush, Sachin Gangwar, Anuj Kumar. Yes, everybody it is telling it is 2 and 2. Good, good. So it is quite logical. See, here you attach a data link layer header. Here you are going to detach actually. Okay. So this is actually it's a LAN actually. So whatever you transmit, everything is frame only. In the transport layer, when I talk about a concurring procedure by talking about data link layer, network layer, and transport layer, a combined stage. When I am talking about a checksum, you will be knowing where exactly the frame, where exactly the segment it will be there. Okay. So here you attach, here you detach, here you attach, here you detach. So what they are asking, how many times data link layer headers are attached? Here you attach and here also you are going to attach, 2 places. And how many places you are going to detach? Here you are going to detach, here you are going to detach. So what is the answer? A is the answer. Okay, like that. Santosh Kumar, correct. Anshu Kumar, good, good. Mansi, correct. You can try this problem. So they are asking, they may ask in 1 mark question like this. That means you have different fields na, when it is transmitting the packet from source to destination. In between end to end, some fields will be constant and some fields is going to change. Based on that ideology, they have given this question. Try. Anupriya, good. Saurav Patel, Komal, Mansi, Rakesh, Vandit. What they are asking, see, which fields will change in between. You know very well, TTL is going to change, na? It is going to decrement at every hop. Okay, like that. TTL is decremented. So, okay. Now, you know very well, what is the purpose of TTL? Because you know the property or a definition, logic of a algorithm or a protocol. Every algorithm should be a finite. It should not be an infinite loop. Okay, so that infinite rotation of the loop, you can make it as a finite by chance if the packet is forming a loop with the help of this TTL, which is provided by whom? IP protocol. What will happen by chance if the packet is forming a loop? Why the packet will form a loop? Routers are going to be having a routing tables with wrong values. Why do they have wrong values? When the links are broken, there might be a chance that packet is forming a loop. So that unwanted scenario of packet rotating an infinite thing, you have to make it as a finite. So to make it as a finite, this TTL is there, this TTL is there. Okay? So it will rotate, so that infinite thing becomes a finite. So packet will be dropped. So there is no real problem for the data packets. But the real problem is for what? The routers are going to be filled with the wrong values, quasi values, unstable values, race values, like that. Okay, like 1, 2, 3, 4, unnecessarily they rotate like that. With what? The routing tables filled with the wrong values. So what should be happen? Along with the packets dropping for a finite time, routers also should be corrected immediately. There might be some procedures like Poisson reverse or link state routing algorithm. Plain distance sector cannot solve the problem. Okay, infinite rotation of a loop, you make it as a finite, that's okay. But parallelly, the router should not have inconsistent data loss, race condition, okay, unstable values, correct values immediately they should have. Otherwise, what will happen? These incorrect values will be given as to other routers. Then they are also going to be filled with the wrong values. Finally, the network is going to be collapsed. So that's why the TTL is going to be decremented at every hop. Okay, that is a rule or the protocol. Because of that, this is the reason what I have explained. Okay. Yes, what is the answer? Good, very good. B is the answer for it. And you know, source IP, destination IP, in between it should not change. So that is the reason the packet will go to correct destination. Okay. Okay. Mega Naik, correct, correct. Rajiv, good. Rajkumar, good, good. Yes, they have given some simple question. You can try. They are asking the, okay, the size of the data or the payload value. Try this problem. Yes, correct. So how to solve it? It's so simple. Header length is given as 1010. Means what is the meaning? 10. But most of the times you will stop at this point. No, but 10 means what? 10 rows. You should know, remember that one. So you have to convert into bytes. 10 into each row is how many bytes? 4 bytes. So try to convert into bytes. So what is the value? 40 bytes. So the meaning of 1010 means 40 bytes. We should not stop at 10 rows. As per the IP protocol, okay, 10 rows means what? 1 row is 4 bytes. Now they are asking size of the data and the payload value. Nikhil, Vandit, Lashasri, very good. So what they are giving? They are giving like this: header, okay, plus a payload value means what? Data combinedly is call it as the packet. Is call it as a packet. We have done this problem. You can say header is 40 bytes plus data how much? You don't know. X you have to calculate. So what is the packet size here? You can see. So it is 2 power 0, 2 power 1, like that you can calculate. Or directly using a shortcut, you can see if you have 8 bits, then that becomes 255. But here you see 7 ones and 0 means 254. So what is the value here? 250. Then what is the data size? X is nothing but what? 254 minus 40. So what is the value? 214 bytes. So 214 bytes is the answer. Moniksha, correct. Mansi, correct. Ankush, very good. Lashya Korade, very good. Ranjan Singh, excellent. Sagar Lodia, very good. Sriza Patel, correct, correct, correct. Now see, this is a MSQ question, but take some time and try to solve it, because here you can see it is a mixed, actually layers are mixed. They are talking about IP protocol as well as the data linklet ARC, and they are talking about IEEE 802.3 also Ethernet. So okay, observe clearly and try to solve it. So they are asking which of the following is true in the network layer protocols. Like for 1 mark question they can give you, but for that you should know every protocol what they are doing. Okay, try this one. Yes, Raman Singh, good. Ankush, very good. Ranjan. Sriza Patel, good, very good. 214 is the answer, good. Vandit Sa, B and C. Kazal, B and C. Razak is telling it's B and C. Let us see. Komal Kandu, B and C. Komal Kumari, B and C. Karthik, Rakesh. Patel, you have to check your answer. You put only a B. It is a MSQ. Yeah, MSQ question. You can see IP provides a checksum only for the IP header, so that entire packet can provide error. Here is the mistake. This is the mistake actually. See, when you are providing a checksum only for the IP header, it provides error control only for the IP header. How can it provides a error control for the entire packet? So that's why A is what? False. Okay, like that. Okay, Karthik, good. Komal Kumari, B and C, good. Mansi, B and C, good. Anupriya, very good, correct. Sombit, correct. CRC can detect all types of errors at a trade-off that a good generator is taken at the data link layer. Yes, in the data link layer, CRC only used. So we have in the derivations also, like if you take x is a bad generator. If you take x plus 1, it is going to detect odd number of errors. Proof also we have given. The CRC32 is the finalizer technique. So in the data link layer, CRC is used. So it is correct. Good, very good. Yes, Nikhil Shukla, you have given the analysis also. Good, excellent. B and C according to RFC. Can you tell what is RFC standard, Nikhil? You have mentioned some RFC there. What is the meaning of RFC? Yes, very good. RFC means it is standard. Like IEEE, RFC is a standard. Means what? Request for comment, you can say. RFC stands for the request for comment. That means what? There are many protocols will be there. IP protocol, TCP protocol, UDP protocol. For all the protocols, latest updations, what exactly the rules of the protocols will be available in this RFC. You can type in the internet also. Okay, you will get the complete data. Yes, Nikhil, very good, good. Okay, like that. The maximum frame size limitation is to give fair and equal chance to all stations in the network. It is also correct, na? So that no station will lead to starvations. All the stations are given the equal chance. So after acquiring, you can send maximum only 15-18 bytes only as per the standard Ethernet. After that, it has to release the channel so that some other station can start sending the data. Okay, minimum frame size 64 bytes is for acquiring a channel. But after acquiring, you can send only 15-18 bytes. Okay, so this is also true. So B and C. Yes, Nikhil, very good, correct. Yes, you can try this question. I will give the hint. See, you know very well the flow control policies of the data link layer. So to the, I am giving the hints. To the data link layer, data it will come from the network layer. Okay, and there is a shared buffer or a common buffer where actually the network layer, whatever he is sending packets, that you have to place it on the buffer. But from the same buffer, this data link layer, sender data link layer has to remove the packets and you have to attach sequence number and then you have to send. And why you call that as a shared one? Because the sender's network layer, whatever he is sending the packets to that buffer, same time he cannot remove that packets and attach a sequence number and can start sending that. It's not possible because that is a shared buffer. Okay, but from that buffer, how many packets has to be taken by the sender's data link layer will be decided by the window size. And they are giving some question. Try this one. You can see they are using go back and ARQ protocol. Some pseudocode is asking generating the sequence numbers. For the stop and wait ARQ, if we take sequence numbers 0 and 1, sufficient. 0, 1, 0, 1 like that sufficient. But if you go for go back and ARQ, they are saying in this problem 3 bits. If it is 3 bits, sender window size is 7, receiver window size is 1. If you take 4 bits, okay, 15 and 1. 6 bits, 63 and 1 like that. But for that you require sequence numbers. So for generating sequence number, which pseudocode is applicable they are asking. Try. Karthik, Sarkar, Raj Kumar, very good. Anuj Kumar. Yuvraj Singh, good, good. Anuj, Monik Shah, good. Raj Kumar, very good, excellent. Pranshu, good, good. Yes, that is absolutely true. Somebody is telling until the sender's data link layer starts sending a frame, until you get the ACK, okay, the sender's data link layer cannot send the next packets you are saying. If the packet buffer is already having, you can start sending by moving the pointers like SF and SN actually. Okay, like that. So here you say 3-bit sequence number. So 3-bit sequence numbers means what? It is like this. You have to generate the sequence numbers 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, so on like that. These values you have to generate. That means from 0 to 7 you have to generate. Why 0 to 7? Because you can see in the problem it is given 3 bits. 3 bits, 8 sequence numbers are possible. But observe here, after generating 8 sequence number, again this 8 sequence numbers to be repeated, it becomes a wraparound. It becomes a wraparound. Okay, like that they are giving. Now see, if we use a mod 4, you can generate only 0, 1, 2, 3 only. But they are asking up to 7. Why 7, 0? Because it is 3 bits. 3 bits means what? 2 power 3. 8 sequence numbers are required. Okay, so 0, 1, 2, 3 only are printed. Okay, so this is false. This is false. This is false. Okay, now if you say I will take mod 16, if I take a mod 16, I am going to get 0, 1, 2, 3 up to 15. After 15, again it becomes a 0, but here you want only 0 to 7 only, 0 to 7 only. But I don't want up to 16, so this is also wrong. And why you are using a mod operator here? Because you can see after 7, again it has to repeat, again it has to repeat for the next frames, whatever you want to send. Okay, like that. Now this is the correct answer, you can see. See, when it becomes a 0, 0 plus 1, 1 mod 8, 1, so next 1 is printed. Okay, next, after that it is going to increment, because it is a true condition, it is a true, you can see always it is true. Then again 1 plus 1, 2, so 2 is printed, 3 is printed like this, 4, 5, 6, 7. Okay, 7 plus 1, 8, 8 mod 8, it is going to get a 0, now see 7 after 0. That is what you want. So what is the answer? C is the answer for it. Yes, Palak, very good, correct, correct. Umesh, very good. Raj Kumar, good, good. Okay. You can try this model also. They are saying that NL, because they are using some word like NL, because it is coming from the network layer, na? So they are using some variable, local variable like NL. What they are saying that is the variable updating regarding the number of packets pushed into the sender's buffer by sender's network layer. Okay, because when you start learning the sliding window protocols at the data link layer, to the sender network layer only is going to give. So they are saying that NL is the variable. Because it is coming from network layer, they put some variable like NL. And DL is the variable updating regarding the packets popped from the buffer and placed in the channel by sender data by attaching a sequence number. You know very well, from the buffer you are going to pick that packets, you attach a sequence number and then you start sending the frame. So that's why it is using another local variable called DL, because it's a data link layer. Share is the one more variable. Share is the variable giving exactly the present number of packets in the buffer. Why? Because you can see network layer as you are pushing the packets, data link layer as it is removing the packets, effective packets whatever it is there, some common variable is required, and that is they are using some word like share. Okay, now you can try. What is your doubt, Vandit? Somebody is asking. Rakesh, Sombit, good. Komal, Ranjan, Monakshi, Sami, good, good, very good. Correct, correct, correct. What is the answer? A, very good. Lashya Sri Koradia, very good. Patel, good. Mansi, good, good. Palak, very good. What is the answer? Yes, very good. See, network layer means what? N. A is the answer. Pransu, correct, correct. You can try this problem. What is the purpose of the shared buffer they are asking? So it is like this. So when I am taking the sender's data link layer and this is the receiver's data link layer. Priya Mahato, Santosh Kumar, good. Vandit, good. Good, good. Lasha, Rakesh Raz, Ankush, Palak, Nikhil, Kartik, Ayush. Okay, everybody is telling C is the answer to retransmit the frame. Okay, C is the. Why not this one? Why not this definite waiting for ACK? Definite waiting. So this definite wait for ACK is for timer. When you start a timer, waiting time should be finite. You have to wait for the acknowledgement. Then if they ask for a timer, that would be the answer. But they are asking regarding what? Shared buffer. Okay. Why do we require a buffer? By chance, if the data is lost or if you don't get a ACK, the timer is going to expire. So you will take the data from the buffer and you are going to again resend. Then you will not update that variable, local variable or whatever the variable, because you are again resending the same packet. Okay, to retransmit the frame if it is lost. They can ask you for 1 marks like this. Okay, C is the answer for it. Yes, Pransu, we will call it as the outstanding frame. Good, good, very good. Santosh, correct. Yuvraj Singh, Anushya Mahapatra, good. Yes, Palak, it requires a timer to expire. Good. Umesh, very good. Anjali, good, correct. Sahu, correct. You can try this question. 12th query. Shall I give the hint? Shall I give the hint? See, they are asking last host of the subnet. That means what? They are not asking DBA. Just DBA. Just DBA ke pehle they are asking. Okay? Means whatever the last one you know, DBA of a subnet, uske pehle jo hota hai na, last. Okay? Last host they are asking. Okay? Try. Shall I give one more hint? Here this is a mask. Okay? Try to convert into binary. Like this. 8 ones. Okay, 8 ones. So again 8 ones. 240 means what? 4 ones, so 4 zeros. Okay, like that. Good. Yes, Nikhil. See, in the previous question, whatever you are asking, that is a common variable now. See, the point is, the whole OSA model or TCP/IP model follows the divide and conquer principle. So the point is what? From the sender side, when the network layer is giving the data to the sender's data link layer, okay, the point is the sender data link layer cannot send any frame if the network layer is not sending any packets. So before actually taking the packets and send it as a frames, it has to check a condition whether that buffer is empty or not. Something like a consumer problem, you can say. Because if it is empty, then the sender's data link layer cannot cannot take any packets. Na? So before actually popping the packets, it has to check a condition whether it is empty. Same like that, when the sender's network layer is pushing the elements or pushing the packets into the buffer, it has to check a condition whether that buffer is full or not. If it is full, he cannot send the packets. Na? So then he has to busy wait, or it has to go to some suspended list, whatever might be. Because the point is, this network, the sender's network layer and sender data link layer are linked. It only gives the data to the sender's data link layer. So the buffer, whatever is in between the sender's network layer and the sender's data link layer is a shared buffer. That's why when the network layer is sending packets, it has to check a condition before whether it is full or not. If it is full, it cannot send a packet. It has to go for some busy waiting or a suspended or something it has to do. Okay, like that. Good. Nikhil, very good. Good question you have asked. Lashya Sri, good. Palak, Sombit, Pransu, Karthik, Anusuya, Rajkumar, Sami, Komal. Same with the case of at the receiver side also, when the data link layer is giving to network layer, there also the same thing it is going to happen. Yes, so you can see by observing this question, these all are the network layer. This 119 I can write like this. Okay, these all are network bits. You can see 119 I can write 0 111 0 111, and you can say continuously ones are there at the ending. When you have continuous ones, that is a probability of becoming a DBA. No? It cannot become a last host. It becomes a DBA. So this cannot be the answer. Like that you can eliminate. Yes, Nikhil, very good. Now you can say these are network bits. This 118 I can write like this. 0 111 and this is what 0 110. Okay, but see, if this value to become a last host for the given mask, you can see these all are the host bits wherever the zeros are there. So host bits are what? 4 bits should be there. But 0 110, does it look like a last host? No, no. Because for the last host, all ones, 0 should be there. All ones, 0 should be there. But do you have all ones? No, no. No, it's not there. So this also cannot be the answer. Same like that here you see these all are network bits. This 30 I can write like this 0 0 0. Okay, 4 ones and 0, and you can say 3 ones and 0. Yes, it looks like a last host, because you can see if it is all ones, DBA. If it is all ones, DBA. Just before number will be all ones and 0 becomes the last host. So what is the answer? C is the answer. Rajkumar, okay, Pamaneni, Moniksha, Razak, very good, Razib, good, good, excellent. Karthik, Sami, very good. Pransu. Okay, Ranjana, excellent, good, good. You can try this question, one more question. So they are asking regarding what? Classless addressing, remember that one. So what are the rules of classless addressing? What in the block contains what? Group of IP addresses. Out of that group of IP addresses, first one will become netted, ending one will become a DBA of the block. But in between all those things, you can assign those IP addresses to the host. But always remember, block means what? Block means what? Group of IP addresses. First one becomes netted, ending one becomes a DBA. In between all are going to become the host. And here they have mentioned that 2 power 16 addresses. Vandit, Ranjan, Mansi, Komal, okay, Nikhil, very good, Neeraj, Rajkumar, Moniksha, Lashyasri, Ankush, good, good. Yes, 2 power 16 means I can write 2 power 8 into 2 power 8. 2 power 8 means what? 256, and here it is 256. So tell me the last octet, I mean the 4th octet. Possibilities are what? As per the rules of classless addressing, what is second statement? The address of a block, the starting address of a block should be exactly divisible by the number of address of a block. So if I take a 4th octet, since it is 256, what are the possible values you are going to have? 0, 256, 512, so on like that. But this is not possible, this is not possible. Because why? Because why? With a 8-bit, you will have 0, ending value is 256, 255. Okay, so the only number which you are going to get is 0. So the point is, when you have 256, always the last octet is 0. Where is 0? Here it is 0. Yes, Neeraj Jaiswal, excellent. Whatever you said, 100% it is correct. First address of a block should be exactly divisible by number of address in a block. Correct. Ranjana Sambal, good. Last year, correct. Now you can see the previous one, 256, and you know it's like mn, mod mn formula, mod m into mod n you can write. Okay, so that's why this 2 power 16 I am writing like this, mod m into mod n. And if you observe the third octet also, same scenario. If I take the third octet, is also same thing. The numbers which are divisible with what? 0, 256, 512, so on like that. But in a octet, minimum is 0, maximum is 255. So the only number you are going to get is what? 0. This is not possible, is not possible. So only 0 only. So here you can see third octet is 0. So C is the answer, like that. If you know the calculations perfectly, you can do it fastly like this. Okay, like this. So you can try these two questions, 9 and the 10th questions. They have given the wildcard mask, wildcard mask. So what is this wildcard mask? Means complement of the network mask. What is the network mask? Normally you will have wherever the network bits are there, make them as ones, host bits are zeros. What is wildcard mask? Inverse or opposite or complement of the network mask. So previously now the network bits becomes zeros, host bits becomes 1. If it is a wildcard mask. Try. Do it slowly, not in a hurry. Vandit, very good. Vandit, excellent. D is the answer. Correct. Some people are saying B. No, please check one answer. Some people are saying it's B and C. Shall I give the hint? Nearest it is D. Nikhil Shukla, D. Good. Yes, see it is slash 29. Slash 29 means what? 2 power 32 minus 29 means what? 2 power 3 means 3 bits. 3 bits. So here 3 bits means what? I can write like this. Okay, 8 zeros. Okay, 8 zeros. Again I am writing. So 8 zeros, 8. Already 24 are done. 8, 24. But here you can see 29 are required. Okay, 5 more means 5 more zeros and ones because it is asking wildcard mask. So all zeros, so 0, all zeros, 0, all zeros, 5 zeros and ones, 3 1 7. This is the value. But is it available? No. What is the answer? D is the answer for it. Okay, like this. Ranjan Singh, good. Patel, very good. Rakesh, Karthik, very good. Good, excellent. Sombit, good. 10th you can try, 10th also you can try. If they ask for 1 mark questions, based on a concept base, they can give like this. Okay, simple concepts. X represents the limited broadcast address. What is limited broadcast address? So 255.255.255.255. This is the limited broadcast address. And now you can see they are saying that it is X. So they are asking number of ones. X how much now? 255 means what? 8 ones. Again 255, 8 ones. Again 255, 8 ones. Again 255, 8 ones. 8 into 4 how much? 32. So what is this X value? 32 plus. What is this Y? Y represents, you can say, DHCP client address. What is the DHCP client address? 0.0.0.0. And they are asking the number of, how many number of ones are there? 0. So 32 plus 0. What is the value? 32. Ranjana, very good. Palak, excellent. Rakesh Raj, good. Akshay Chatterjee, good. Mansi, Pransu, okay. Patel, very good. Vandit, correct. Pransu, very good. Yes, okay. Take a little amount of time for a few seconds and try. not be in a hurry. A small logic is there in this question. You might be knowing well about exponential backoff algorithm. Okay, you can apply in a standard Ethernet or in a wireless LAN also you can use, no problem. When you are going to use a exponential backoff algorithm, when there is a requirement that stations has to wait some random amount of time, you can use. Okay, think what they are asking. Don't be in a hurry, okay? Think what they are asking. Some people are saying it's B, some people are saying it's a C. Okay, think, that's what I'm asking. You have to, small twist is there. Small twist is there in this question. You can see here it is a standard Ethernet, means IEEE 802.3. Okay, and you can see collided for the first time. So this is logic like this. A and B, they have transmitted for the first time and it is collided. That is the meaning. Okay, Sombit, some people, Lasha, okay, Ranjan is telling it's B, Razak it is telling is C. Let's see if any other answers. Rajkumar it's C. Kajal he is telling it's B. Okay. Ayush Chavan B. Okay, now see, here the data is collided. So K is equal to 1. Why? Because the data is collided for the first time. Then what is the waiting time of station A? Is nothing but is given by formula what? 0 to 2 power K minus 1 into what? Pt is the propagation time. Then what is the waiting time of station B? It is given as 0 to 2 power K minus 1 into what? Pt. Okay, like that. Okay, now you can see K is equal to 1, then the waiting time of station A, then the waiting time of station B. K is equal to 1, if you substitute it is 0 and Pt. Here also what? 0 and Pt. Okay, like that. So why you are applying exponential backoff algorithm? As the K value increases, the chance of collision is going to what? Decrease. But they are not asking that one. You think logically what they are asking. What is the maximum, see, bounded waiting time by a station, either A or B. Okay, now here you see when A and B, this waiting time of station A, he can wait a time of 0 time or a time of Pt time. So in this, what is the maximum bounded waiting time? Pt time only. Pt time only. So what is the answer? Pt. So that you have to observe. That is observe. Okay, like that. If suppose the same problem, if the data is collided for the second time, then the chances will be very high possible, like 0, Pt, 2 Pt, 3 Pt might be his waiting like that. But they are applying only for the first time the data is collided. Okay, good. Umesh Chandra, good. Okay, only Pt. Kajal, good. Ranjana, good. Lasha, correct. Rajiv, good. So Pt. So like that, what exactly they are asking of, sometimes you have to observe clearly. Okay. You can try this one. They are saying that maximum bounded waiting time they are asking. Okay, fine. You can try this one. Nikhil, Rakesh, Sarkar, Palak. Okay. Vandit, good. Koradia, C. Okay. Anus Kumar, very good. Sami, good. Yes, what is the answer? What they are asking? Yes, IEEE 802.3 or a standard Ethernet. What is the limit of the frame? Okay, to ensure that, you see this word, ensure that a progress or remaining stations are getting a chance. Means what? Here there is no starvation. To give fair and equal chance they are asking. So you have to consider the minimum boundary or maximum boundary. Maximum, minimum is how much? 64 bytes. For what purpose it is 64 bytes? To acquire the channel, you have to spend a time of what? TT is equal to 2 into PT. But after acquiring a channel, does the station can continue transmit the data? No. They put a maximum boundary, how much? 15, 18 bytes. Why? To give a fair and equal chance to all the stations. So what is the answer? 15, 18. If they ask a same question for a payload value, then it is 1500 only, because the headers can be removed. Okay? C is the answer for it. Yes, correct. Yes, you can try this fifth question. This is a MSQ question they are giving. Take 1 or 2 minutes. It may take a little more time also. Okay. Quite logical question. You have to do it slowly. Okay, and try. Yes, everybody is doing correctly. All the questions almost doing correctly. Good. Shall I give the hint? Okay, fine. See, I will give the hint. /17. Okay. So this I can written as 2 power 32 minus 17. Or this I can written as 2 power 15. Or this I can written as 2 power 7 into 2 power 8. So this you have to remember. 2 power 7 into 2 power 8 means what? 2 power 7 will be in the third octet. 2 power 8 is in the fourth octet. Okay, like that. Good. Now these models also, there are many times they are giving this type of model questions they are giving. You can check the previous GATE papers also. Okay, like that. Yes. See this value, if you want this value means what? How much you require? 1500. Means 1500 means, okay, how you write the closest value is what? Can I take a 2 power 10? 2 power 10 is 1024, which is not supporting this value. Can I take 2 power 11? Yes, 2 power 11 is 2048. Okay, like that. So in this 2048, this 1500 is satisfied? Yes. So this gives you an idea. Okay, 2 power 11 means what? 2 power 32 minus how much? 21. Okay, like that. Okay, good, very good. Yes, it is a MSQ question. You can say MSQ question. Do it slowly, not in a hurry. Do it slowly. Yes, this problem is giving you an idea, you can say, because after solving also you have to cross verify. You end up with a wrong solution also. That's why I am asking you to do it slowly. So now you see this 2 power 11. I can write like this. I am giving one more hint. 2 power 3 into 2 power 8. So here whatever the requirement is there, this 1500 is, this is the value of this one. That means third octet and fourth octet. Third octet and fourth octet you should take. Do it slowly, do it slowly. Okay. It is a MSQ question. I think last year they have given this model only. Last year, if you observe the previous GATE questions, this type of model will be available. Neeraj Jaiswal, Nikhil Shukla, Neeraj Jaiswal. Some people are saying it is B and C. One person, let me help you, saying that B, C, D. Let us see. Shall I give one more hint? Okay, so now here you see I am taking the last two. So 0 dot 0. So this 0 I can write like this. You can see 8 zeros dot this 0 I can write like this. Okay, 8 zeros. You can say now you require 3 bits and 8 bits. So here I am taking these 3 bits and 8 bits like this. Okay, like that. So you can drop these numbers 0, 0, 0, 0, 0 and you make them as what? All ones. Here also you make them as what? All ones. So this is the starting address and this is the ending address. Okay, like that. Take a little time, it will take some time. Okay. So now if you observe, that means just applying the concept, it's not sufficient. You have to do calculations also. Okay. So here you can observe that 0.0 slash how much it is 21. 2. What is the value? You can see this value is how much? 7.255. 7.255 slash 21. This is the range of that, this particular requirement of this 1500. Okay, like that. Yes. Pranshu, you are saying that it is B, C, D. You got B, C and D, but there is a mistake is there at ending. You have done up to, at the ending, up to ending you have done correctly. Lastly, small mistake is there. Patel, you just check that one. Neeraj is finding out that one. That's correct. Good. He has given the analysis also. Now see. If I have gone for it, the next one is what? 0, 0, 0, 0 and 1. And you make it as what? All zeros. So here also it is what? These all are all zeros. So on like that. 0, 0, 0 and 1. And here you can make it as what? All ones, like this. Because you always know the right side numbers belongs to left side series. Right side numbers belongs to left side series. Okay, like that. So what is this value? 8.0 slash 21. Because you can see mask is 21. 2. How much this value? You can see what is value? 15. 15 dot, okay, 255. Okay, so those students who are saying that B, C and D, they have done correctly up to end, but at ending they have not checked a small point actually. Those who are saying that B, C, D, at ending a small point you have not checked. Okay, like that. Yes, 0, 0, 0, 1, 0, because 0 series is 0, 1 series is completed. The right side numbers belongs to left side series. So here I can write here 3 zeros, okay, followed by what here? Okay, 8 zeros. Okay, so on like that. So 0, 0, 0, 1, 0, and you can have what? All ones. Okay, like this. So what is this number? You can see how much it is? 16. Okay, 16.0 slash 21. Okay, 16 plus 7, how much? 23. So 23.255 slash 21. So on like that you can calculate. But now you are able to understand the pattern also. Okay, so what is the pattern? You can see here it is 0, you can see third octet. Here you see the starting 8, third octet. Here it is 16. This gives you an idea that it is acting as a multiple, I mean the factor of 8 you can say. So what are the answers? You can say like this. You will directly third octet 0, 8, 16, 8 2s are 16, like that you can write 24. Okay, then 32, 40, or you have to check up to all the values. If you know this logic here, you can apply here. Then 48. Okay, like that, because you can observe every time 8 you are getting. 56. Okay, 64. Okay, like this. 72, 80, like this. Yes, some problems may take a little more time also. Okay, like that. Why they will give every problems as easy. Okay, like this. 88, then 96, 104. Okay, like that. 112. Then 120, 128. Okay, like that. 136. Okay, 144, like this. So on. So because multiples of 8 now you can see. So if you observe ABCD options, see the first option is 84, you see 84. Now see 72 is there, 80 is there, 88 is there, you can see 80, 88, 84 is not there, 84 is not there. So this gives you an idea, A cannot be the answer. That's what I am telling. The people who has done up to ending B, C, D correctly, but at ending a small point you have not checked. I think Kumar is also telling it's B, C, D. Na? You have not checked the D value. Rakesh Ras, good, very good. Now you can see here you have 104. 104 is the third octet. You can see here third octet is what? 104. 104 is there? Yes, you can see it is available. So here B is the correct one. You can say fine. But see, this question is a MSQ. MSQ. Yes, last year this model they have given. Okay, like that. Then if you observe the third one is 64. 64 is available. Yes, you can say 64 is available. Okay, like that. So you can say C is also correct. C is also correct. Okay, and you can see option D. Here you have 144. 144 is there? Yes. If you put D as tick, that means at last point you have not observed. Lastly you have not observed. The point is you observe here. Here it is 2 power 7 into 2 power 8. This is the most important thing. 2 power 7 into 2 power 8 is the actual block. Okay. So the concept is where you miss it, that I am telling here, you see. Here the actual block is 0.0 is there, na? That I am writing here, you can see. Once again, so 0.0. See, this 0.0 is nothing but what? Okay, I am writing the actual block. So I am telling you why you put 144 as also a tick mark as an answer. That I am telling here. Okay, see, this 0 I can write like this. 8 zeros dot again what here? Okay, 80. That means the actual block they have given, you can say slash 17. Na? Slash 17 means 2 power 7 into 2 power 5. That means from this 7 bits to and here 8 bits I should take here the range. So now if you observe here, if I have taken this 0, okay, and I can make here what? All ones. Here also I can make what here? All ones. Now you see the original block range. Original block range is what here? You can see 0.0 slash. You can see this value is what? 17. You can see slash 17. 2. Yes, you got the answer now. See, what is value? 071. 071 means what? 127. 127 dot 255 slash what? 17. Good. Now you see the logic. The third octet is ending with 127 only. This is the most important point which you have to observe. Okay, that means what? After 120, these all will not be possible. Will not be possible. That you have to observe. Okay, up to 120 only possible. So here, even this 144 is satisfying. You can say 144 is not possible here. From the actual block is not possible. That is where you may find a mistake. This gives you an idea. B, D cannot be the answer. They have given the option B, C, D also. Then you end up with a wrong answer. So for this problem, what is the answer? B and C are the answers. Okay, like this. Okay, understand where exactly you might be doing a mistake. Okay, good, very good. Got it? Good. It's a MSQ question. You can try. This is regarding TCP. Try. Good, very good. Yes, Pranshu, very good. Komal, very good. Ankush, very good. MSQ Rajiv, this is MSQ. Nikhil Shukla, good, very good. A and D. Palak, A and D. Kajal, very good. Ranjan, very good. Vandit, very good. Rajkumar, excellent. Rajiv, good. Ankush, excellent. The self, what is the meaning of self clocking means? See, basically in case of TCP, you transmit the segments. Okay, even some segments are lost in the network, no problem, because the receiver TCP is going to accept what? Out of order segments, but always sends what? In order acknowledgement. This in order acknowledgement is a self clocking or giving an indication to sender, you please again send that missing segment. That is called self clocking actually. Okay, understand? That means you don't require any ICMP. That itself can detect now. Suppose you can say, when you say IP packets are dropped, ICMP is going to inform, but ICMP can be lost. Until and unless ICMP has informed, source cannot send the packet. But TCP is not like that. If some segment is dropped, let them drop, no issue in it. Because TCP is going to accept what? Out of order segments. But always sends what? In order acknowledgement. So this in order acknowledgement is going to self clock or giving indication to the sender, you please again send that missing segment. Okay, like that it's called self clocking. So it is correct. Sakshi, correct. Anu's very good. Umesh, Neeraj, excellent. Pransu, Sombit, good, good. Ayush, very good. And you know UDP is okay, connectionless. Simple, because UDP protocol doesn't have any sequence number. Okay, every datagram will travel independent. At the receiver's transport layer also UDP datagram will not wait for the remaining datagrams. It will immediately given to the application layer. So it is a connectionless. Yeah, TCP is a connection oriented virtually with the help of sequence number. Segments will wait, na? But UDP will not wait. Datagrams will not wait. You can see TCP supports broadcasting. Okay, this is false. As there are sequence numbers are there, but broadcasting, how it is possible? Because the sequence numbers only, broadcasting is not possible. Okay. UDP is unreliable and supports broadcasting. Yes. So what are the answers? A and D. Okay. Because why it supports broadcasting? Because UDP has no sequence numbers. You can send the same data to the multiple computers by using the broadcast address. So what is the answer? A and D. Yes. Very good. Excellent. Everybody has done correctly. It is some MSQ. This is also MSQ they are asking. Okay, you can try MSQ. Okay, see the fragment offset, what they are giving, the fragment offset of a packet will not be same or equal to the fragment offset of, you can say all fragments of the same packet they are telling. Okay, will not be same or equal to. Yes, correct. So how? Suppose it's like this. I can take some example. If there is a LAN having some MTU, I am taking it is some 200 bytes. Okay, the packet came from outside, suppose. Okay, the packet size is 600 bytes. So 600 bytes I can written as what? 20 and 580, like this. And this MTU I can written as what? 20 and what? 180. So you can observe this packet size is more than MTU. So fragmentation. So when you try to do fragmentation, here you are going to get fragments as what? 0, 22, 44, 66. And what is the fragment offset of packet? Here I am taking 0. That is the address, no? So it is not matching with remaining all now. You can see fragment offset of a packet, fragment of packet will not be same equal to all. You can see all fragments. Okay, like that. That is true. Okay, Palak, Sakshi, very good. Okay, Rakesh. Now you can see ICMP error message can be transmitted not only by the mediating routers but also by the destination host also. Yes. For example, you are sending the data to a unknown port, like for example, HTTP protocol you are using, and there the destination port number is what, 80. Suppose you send with some unknown port like 81 or something, it will reach up to destination, but at the destination process it will not accept. So there the ICMP is sent by the destination also. So not only by the mediating router, destination also. So it is correct. And in case of persistent, what? HTTP by default, okay, HTTP 1.1, we will call it as the persistent, you can say. Persistent HTTP. So basically what is persistent HTTP means what? Okay, you can access n number of objects in the same connection. With the same connection you can object. So this is also correct. So A, B, C. It is a MSQ question. Okay, good, very good. Okay. This is a wireless concept, that is 802.11 or CSMA by CA protocol they are asking. And they are mentioning that A and C are nodes and B is the access node. They are mentioning B is the access node. You can try. Good, very good. Okay, so what is the answer? Nikhil, Vandit, Neeraj, yes. When both A and C sends RTS at the same time. So when A is sending RTS and C is sending RTS, okay, then there will be a collision. Okay. So when there is a collision, actually when A and C are transmitting RTS, in return to that, what do they expect? CTS. So not getting the CTS is a confirmation that here there is a collision. Then A and C, they are going to apply what? Exponential backoff. So what is the purpose of exponential backoff algorithm? So out of this A and C, anyone is going to send RTS before the other one so that there won't be any collision actually. As the K value increases, the chance of sending RTS by either A or C will be more compared to the other one. Okay, like that. Okay, like that. Okay, now you can see this is the question. Yes, this is called the hidden node problem. This hidden node problem can be solved by what? CSMA by CA. But CSMA by CD, why it cannot solve? Because parallelly if you send at the same time and if there is a collision, that cannot be detected by either A or C if you apply what? CSMA by CD. But CSMA by CA can solve the problem. Okay, like that. Okay, good. So we have covered some important model questions covering the concepts, questions, and good, everybody has participated well. And so 95% everybody has given all the questions correctly. Okay, hope you have enjoyed this session well. Okay, thank you very much. All the best for your future. Thank you. Palak, thank you. Vandit, thank you. Raja. Mansi, Sreza Patel. Thank you. Nikhil Sukla. Komal Kumari. Neeraj Jaiswal. Ankush Skashwaga, Raj Kumar, Mansi, thank you. Anush, Sakshi, Anupri, thank you very much. Thank you, Sarkar. Thank you, Tushar Chaudhary. Thank you very much. Thank you, Rajak.